Okay, so in this video we are going to have a look at a Leaving Cert higher level complex number exam question. So we see here, we're just going to highlight what we have. That'll help us figure out what we need and what our process is. So they tell us z equals 1 plus I, w is 1 over z plus I, so we'll have to figure that out. They remind us that I squared is equal to minus 1, and then the question itself is to find the exact value of the argument of w, which is theta. So first thing we're going to do here, 1 over z is 1 plus I, and then what we need to do here is write as a single fraction. So my LCD is going to equal 1 plus I. So that'll give me 1 plus I times 1 plus I all over 1 plus I. Multiply at the top, you get 1 plus I squared over 1 plus I. Tidy up, I squared equals minus 1. So 1 plus I minus 1. 1 minus 1 is 0, so we get I over 1 plus I. So we have W equals I over 1 plus I. And then here we need to multiply top and bottom by the conjugate of the bottom. So the conjugate of our denominator here will be 1 minus I. So that's I times 1 minus I over 1 plus I, 1 minus I. So we get I minus I squared over 1 plus I minus I squared. They told us I squared is minus 1. And then 1 plus I minus I will be 0I minus 1. So that's I plus 1. 1 plus 1 will give me 2. So we get 1 plus I over 2. So we'll just write them separately. So W is equal to a half plus a half I. Draw a very quick sketch of that. There's W. There's my half and my half. And there's my argument. So we have tan theta is equal to a half over half. Theta will equal tan inverse of a half over half. Into your calculator, they don't specify degrees or radians, so either one will work. So into your calculator, tan inverse of a half divided by a half will give you pi over 4, or else 45 degrees. Okay, so just to state your answer at the end, argument of W equals pi over 4, whereas argument is 45 degrees. Okay, that's part A answered for 10 marks. We'll have a look at part B now. So we're being asked to find the real numbers P and Q such that, and they give us this equation, and they remind us again I squared equals minus 1. So first thing I'm going to do here, I'm seeing brackets. Brackets means multiply. So we have 2 times P plus IQ plus I times P minus IQ equals 5 plus I. Multiply out. Tidy up the left hand side. I see an I squared here. I'll substitute that for minus 1. Okay, So I have 2p minus 1 will give me plus q. I'm going to move that here. And then I get plus 2iq plus ip equals 5 plus I. So my next part now is to put reals with reals and imaginary with imaginary. So we get two equations essentially. So we have 2p plus q equals 5 and 2iq plus ip equals I. Okay, so if we check this equation here, I can rewrite in terms of q. So we have q is equal to 5 minus 2p. My other equation, I'm going to drop the i's as they're common, so I'm left with a 1 here on the right hand side. So I get 2q plus p is equal to 1. Now I know I've gone and rewritten q, so I can substitute it in here. So we get 2 times 5 minus 2p plus p equals 1. 2 5s are 10, 2 2s are 4, plus p equals 1. So 10 minus 3p equals 1. 10 minus 1 equals 3p. 9 equals 3p. Divide both sides by 3. And we get p equals 3. Okay, we found p. Now we need to go and find q. So I can pick either one of the equations and sub back in. I'd rewritten this one, so I'll use that. And there's my solution for q. So just to come back up to the question, they had asked us to find the real numbers p and q such that 2 times p plus iq plus I times p minus iq, the part we multiplied out, equals 5 plus I. So just to double check your solution at the end, you just want to sub in. This isn't a necessary step, but it's no harm, just for peace of mind. So we had 2 times p, we know is 3, plus I times minus 1, plus I times p, which is 3, minus I times q, is equal to 5 plus I. So that's 2 times 3 minus I plus I times 3 plus I equals 5 plus I. 2 3s are 6 minus 2I plus 3I plus I squared equals 5 plus I. So we get 6 plus I squared will give me minus 1. Minus 2I plus 3I is plus I. And then just to tidy up, 6 minus 1 on the left side gives me 5 plus I equals 5 plus I. And that's us good. So p equals 3 and q equals minus 1. So 5 marks for that question. Really just a bit of multiplying out, expand your brackets, tidy up, that kind of thing. Pretty straightforward. Okay, part C now, 5 marks again. We're being given Z1, it's in polar form, and Z2, also in polar form. They want us to evaluate Z1 multiplied by Z2, and then they tell us the answer must be in rectangular form. So for when we multiply in polar form, we add the angles. And multiply the moduli. But we've no moduli here, so that's fine. So we have Z1 is cos of 4 pi over 3 plus I sine 4 pi over 3. Z2 is cos of pi over 3 plus I sine pi over 3. So Z1 by Z2 will equal cos of 4 pi over 3 plus pi over 3 plus I sine 4 pi over 3 plus pi over 3. So what happens here essentially is we treat these two and then these two, a like with like approach. So Z1 by Z2 then will be cos of 5 pi over 3 plus I sine 5 pi over 3. And now just a bit of calculator work, make sure you're in radians. Z1, Z2, so you're going to evaluate cos of 5 pi over 3 will give you back a half, and then sine of 5 pi over 3 will give you back minus root 3 over 2i. And that's that question answered for 5 marks. So again, pretty straightforward, 5 marks. You just needed to remember that when we're in polar form and we're asked to multiply, we multiply the moduli, but we add the angles. And if we were asked to divide them, we would divide the moduli and subtract the angles. Okay, that's part C done. And now our last part, part D. They've given us W1, W2, and they said to prove that the conjugate of W1 by W2 is equal to the conjugate of W1 multiplied by the conjugate of W2. So a little bit of setup work to do beforehand, and they tell us W bar is the complex conjugate of W. So first thing I'll do is W1 is A plus IB. I'm going to find the conjugate of that. It'll be A minus IB. W2 is C plus ID. The conjugate of it will be C minus ID. Okay, so that's this part here. I found it. And now we need to work on this part here. That'll be our work here. So W1 by W2 will equal A plus IB times C plus IG. So that's AC plus IGA plus IBC plus I squared BD. We know from above that I squared is equal to minus 1. So that's AC plus I times AD plus I times BC plus minus 1 times BD. We can tidy that up. It'll be AC minus BD plus I times AD plus I times BC. Okay, so we found W1 multiplied by W2, and the second step for us now is, I suppose it's probably a bit easier to maybe rewrite it. The second part we can factorize if you want. You could write it as AC, that'll stay the same anyway, and then you can factorize out your I plus I times AD plus BC. So for us it'll be AC minus BD minus I times AD minus I times BC, or else if you'd factorized, it'd be minus I times AD plus BC, which when we go and multiply out anyway, we'll get the same answer. So we found W2 now. So last step to show is W1 by W2, the conjugates. So we're going to multiply them together. That's A minus IB by C minus ID. And then we have plus I squared BD I squared is minus 1. I times AD minus I times BC. And there's my answer for the two multiplied by each other. So for us now, we have the left side and then the right side. So just our statement at the end. Okay, and that's us done for 10 marks. So again, straightforward enough, 10 marks once you got your process correct. And that's that question answered for 30 marks. And that's us done.